All right, the final method that we're going to learn is the elimination method. And here are some basic steps to help guide you. All right, so number one, the equation terms need to be rearranged so that both equations have the same form. So if we want them both in slope-intercept form, or we want them both in standard form, but they need to have the same form. Okay, so variable lines up over variable, the equal sign lines up over itself, the constant number over itself, that sort of thing. All right, second step, we need one pair of like terms to have opposite coefficients. And you may need to do some multiplying right here. It says you can multiply an equation by a number to make this happen. So I'll show you how that works. And then finally, you're going to add the equations together, which will eliminate a variable. And then you solve for the remaining variable. And so let's see how this plays out. Okay, so here we go. First example, we're going to use elimination. And you should notice that both of these equations are in standard form. Okay, and also the x's are lined up over the x's, the y over the y, and the constant term over the constant term with the equal signs lined up. Everything is very ordered. All right, that's step one. Everything needs to be rearranged so that we have the same form. Part two, we need a pair of like terms to have opposite coefficients. So let's take a look at what we have. So when we look at the x's, those are like terms. The coefficients in front are just ones. Now those are like, those are the same number. Those are the same coefficients. We need opposite coefficients. Let's underline that. We need opposite coefficients. So that would mean opposite numbers like 3 and -3, 4 and -4, things like that. Look at the y's. The coefficients on the y's are opposite numbers. They're 3 and -3. So we have that met. And now we're on the third step. It says we've got everything perfect. The equations are in the same form. We have opposite coefficients where the y's are. So now we're going to add the two equations together and solve for the variable that's remaining. So look what happens. So literally, I'm just going to draw a line and add them together. So I'm going to add 1x and 1x. So we're just put a plus sign out here. That gives us 2x. Then I add 3y and -3y. Well, we already know if you have opposites, that adds to 0. So I don't have anything here. And then finally add the constants together. That gives us 14. And look what we have left. We just have a very simple equation to solve for x. Divide both sides by 2. And we get x equals 4. And then we do need to finish this off. Remember, every solution is an ordered pair. This is a system of equations with variable x and y. So all we know is what the x coordinate is. Now we need to know what the y is. So we're going to have to take that 4 and plug it into one of the equations. Again, it doesn't matter which one you use. I tend to pick the one that has positive coefficients in front of the x and the y. I like that. I try to avoid negatives, but either one's going to work. You choose. All right, so I'm going to use the first equation. So I'm going to do x plus 3y equals -2. So where the x is, I put my value of 4. So x equals 4, so that means I have 4 plus 3y equals -2. Again, where did that come from? I took this equation here, and right where the x is, right there, I'm plugging in the value of 4 that I got before. So 1 times 4, that's my 4 right there. Plus 3y equals -2. Okay, so just plugging in the 4 into this equation. And then solve. So now I've got an equation with just y that I need to figure out. So I'm going to solve for y, subtract 4. So I end up with 3y equals -6. And divide both sides by 3, and you get y equals -2. Put those together. So x equals 4, y equals -2. That's our solution. All right, do it again. All right, look at these equations. First off, you need the form. So I can see that these things are not lined up. I've got 5x, I've got the x by itself over here on the left, but now this x is with the y. So I have to decide what I'm going to do. I need to get this cleaned up here. So what if I have standard form in the bottom? What if I get standard form on the top? So essentially it means I need to move that 2y over. So how do I do that? I'm just going to add 2y to both sides. So I'm going to add 2y here, and I'm going to add 2y on the left side. And let's rewrite. What do we have as a new equation? Negative 5x plus 2y. And then on the right side, these are opposites and they cancel, and I end up with just 13 on the right side. So now the top equation is in standard form. And then I'm just going to bring this right underneath. All right, and so standard form for both. Now take a look. I need a pair of opposite coefficients, and I have that here with the x, the like terms involving x. Negative 5 and positive 5, opposite numbers. So I'm ready to go. It says in the third step, add the equations together. Okay, so let's do it. Just draw a line, add them column by column, like term with like term. So 5x and negative 5x, that adds to 0. 2y plus y is 3y. And 13 minus 1 is 12. So 3y equals 12. Divide both sides by 3, and you get y equals 4. All right, again, you need to know what x is, so we're going to need to do a substitution. Pick any equation you want. You can use the original equations, or even the one we changed is an equivalent equation, so you can use that. I kind of like this first equation because it's almost solved for x. We still have that negative 5 right there, but I'm just going to leave that. So I'll use negative 5x equals 13 minus 2y. I'll use that original equation, and I'm going to plug y equals 4 into it. So I get negative 5x equals 13 minus 2 times, and 4 for the y. Solve for x. See, 12 minus, 2 times 4 is 8, so 12 minus 8 is 4. And then divide both sides by negative 5. And so that gives me x equals negative 4/5. And then I put that together. Now I'm just going to check my word because I can't remember if that solution had a fraction solution. Doesn't mean that it's wrong, but I do want to make sure it's correct. So I'm just going to pull out an extra sheet of paper here and verify my solution, because if I've done something wrong, then I need to go back and check, and maybe this would be a good opportunity to show how that would work. So let's double check it. So if I plug in, I'm going to start with this equation, and I'm going to see if it's a solution. I'm rewriting the first one, minus 2 times y, and I'm going to plug in those values. Negative 4/5, comma 4. That was my solution. All right, so just verifying the signs. Yep, okay. All right, so plug that in, and I get negative 5 times negative 4/5 is equal to 13 minus 2 times 4. Okay, on the left, this reduces, this is positive 20 divided by 5, which is 4, equals 13 minus 8, which is not, that's 5. So I have done something wrong. Let's go back and check my math. Okay, so let's see. I'm going to start from the beginning and just verify my work here. So this is negative 5x and 13. I subtract 2y, so I added 2y. So that's negative 5x plus 2y equals 13. 5x plus y equals negative 1. Check. Okay, these are lined up. 0 out. 2 plus y is 3y. 13 minus 1 is 12. Looks good. Y equals 4. I feel pretty good about that. Oh, y equals 4. So now I'm going to substitute in. So I have 13 minus 2y. Oh, I see it. I don't know if any of you caught it from earlier on. I wrote 13 here and 12 there. So now I found it. So this is the discrepancy. I changed the number. So I'm going to go back and calculate it. Change that back. So let me just write it like this. That was a 12. I was supposed to be a 13. So I'm just going to fix that now. And 13 minus 2 times 4, 13 minus 8 is 5. So I change that to a 5. And then when I simplify, so this answer is wrong. 5 divided by negative 5 is negative 1. Now I feel a little more comfortable because I didn't think that was a fraction when I built this problem. Okay, so it's kind of good to go back and check your work and make sure everything is correct. Let's go on to the next example. All right, so we have everything lined up. Now, it's not any form that we've had, but we do have y over y. We have negative 3x over negative 7x. We have the constant terms lined up, the equal signs lined up. So they have the same form, just not one of the forms we've used before. And we need to have opposite coefficients. So we look at the x's. I have negative 3 and negative 7. They're the same sign and they're also different numbers. The y's have the same number. That's good. I just need them to be opposite. So what we can do is change one of them to a negative so that we get the opposites. We do that using multiplication. So I'm going to take one equation and multiply it by a negative number. And it doesn't matter which one we choose. So for instance, if I take the bottom equation and I multiply it by negative 1. Now I have to distribute. I'm really multiplying both sides by negative 1. And so let me just show it. This should be accurate. So multiply by negative 1 on both sides. Okay? And then let's rewrite the equation. All right, so this becomes negative 4y and on equals. And on the right side, we have negative 1 times each of those terms. So that becomes positive 7x. And negative 1 times the second term is positive 14. And then I take the first equation, which I haven't done anything to, and I'm just going to write it right underneath. So 4y equals negative 3x minus 6. And now I have opposite number coefficients, and I'm ready to do elimination. Okay, again, what I did was I multiplied both sides of the equation by negative 1 to get that negative that I needed. All right, so now let's add. On the left side, the opposite coefficients add to 0. So I have, since there's nothing else there, I have to bring the number 0 down. I can't just leave it blank. 7x minus 3x is 4x. And then this is going to be 4x minus 6 is 8. And then we're going to solve this equation. So subtract 8 from both sides. I get negative 8 equals 4x. And then divide 4 on both sides. I get x equals negative 2. So that's my value for x. And then I plug it back in to get the y. So I'll just use the first equation. All right, 4 times the y value equals negative 3x minus 6. All right, so x is negative 2. Oops, replacing x, not y. My bad. 4 times y equals negative 3 times x minus 6. So what I'm going to replace is this x here. 4 times y equals negative 3 times negative 2 minus 6. 4 times y equals, simplify that right side. So this is 6, positive 6, minus 6. So 4 times y equals 0. And so divide both sides by 4. and we get y equals, remember 0 in the numerator, this is just 0. So ordered pair, our solution is -2, 0. And okay, so let's try the next example. I wanted to show you an example. Sometimes you have to multiply by something a little bit more complicated than -1. Let's see. Look at your everything's in standard form, so we got the same form. We do not have opposite coefficients. So when I look at the coefficients, I have 6 and 2 with both negative, and I have 5 and 4. Now they're opposite in sign, but they're not opposite numbers, okay? So now what I'm going to do is multiply by a number to get opposite numbers. So what would be the best plan? Well, I need a number that I can multiply to. So if I look at these two, I could multiply this to become a +6 easily if I multiplied by -3. So that would mean I got opposite coefficients. Here, I can't do that as easily. I need a number that 5 and 4 both multiply to, and that would be a common multiple of 5 and 4. And that number is 20. So that means I have to multiply the top equation by 4 and the bottom equation by 5. So I have to do 2 multiplications. So I'm really thinking the best choice is to change the x's. I'm going to take this bottom equation, multiply both sides by a number that gets this to +6. And so that would be -3. -3 times -2 is +6. Do the same thing on the right side. All right, rewrite your equation. It's really important to do the rewrite. So multiply, distribute. So that's 6x. -3 times -4 is 12y. And then on the right side, -3 times 14. And that's -42. So my second equation has now changed to this. And then I'm going to take that first equation, just put it right underneath. -6x plus 5y equals 25. Okay, and I have opposite coefficients. So this first pair are going to zero out. And then add 17y equals, and then combine these, that's -17. And if I divide both sides by 17, I get y equals -1. So I've solved for y, plug it back in, and get the value for x. So pick an equation, doesn't matter. How about this equation? I'll just use this one. So 6x plus 12y, and instead of y, I'm going to use -1. And that's equal to -42. Okay, so just plugging in x equals -1, or y equals -1. So I have 6x, multiply this out, and minus 12 equals -42. And then solve. Put it together now. So my ordered pair is -5, -1. Okay, so just trying to get you lots of examples where things can be messed up. So you can see in F, we've got a lot, just a big mess here. Nothing's lined up. But just look at it carefully for a moment. Can you think of a plan? I'm seeing they really kind of do have the same form. It's just one is a flipped equation of the other. This one has the y by itself and on the right, and the x is on the left. This one has the y by itself on the left and the x and the constant term on the right. So what if I just flip one of them and get that fixed up? So that's the first thing I'm going to do, is just kind of get the right form. I'll flip the first one. So I'll put 4y on the left, 2x minus 6 on the right. Let me bring the other equation over. Just leave it the same. Okay, so then the next step is to get opposite coefficients. So form first, then opposite coefficients. All right, take a look. Coefficients here are 4 and 7, not opposites. 2 and -3, they're not opposite, just opposite sign, but not opposite numbers. So I've got to change both equations. Common multiple of 4 and 7 is 28. A common multiple of 2 and 3 is 6. And they already have the right sign. So I think I'm going to do is I'm going to get the top equation to be positive. This will be a positive 6 by multiplying by 3, and this will be a negative 6 by multiplying by 2. So I'm going to do that. I'm going to take the top equation and multiply by 3, and the bottom equation and multiply by 2. Now this is a little shorthand way. Instead of writing multiplying 2 on both sides, this is my shorthand way of showing that. Let's take a look at what the new equations would be. Distribute, multiply everything by 3 on the top. All right, and then multiply everything in the bottom equation by 2. All right, so now we have our opposite coefficients, 6 and -6. Now I know those will eliminate. So I add the equations together, like term with like term, and we have 12 and 14y. 12y and 14y is 26y is equal to, all right, 6x minus 6x is 0. And also 18 and -18, that's also 0. So this right side, both went to 0. So that's equal to 0. And if I divide both sides by 26, I get y equals 0. All right, so let's substitute that in and solve for x. Let's pick one equation. I'll just pick the top. 2x minus 6 equals 4y. But instead of y, I'm plugging in 0. All right, and simplify. So 2x minus 6 equals 4 times 0 is 0. Let's add 6 to both sides. So 2x equals 6, and if I divide by both sides by 2, I get x equals 3. Put it together, 3, 0. All right, it's time for you to try some of these on your own.